Okay, last video. So we're going over titrations now, and this titration is going to be very similar to those stoichiometrical calculations we went over last time. This deals with acids and bases. So titration is a method used to determine the unknown concentration of an acid or base by performing a neutralization reaction when you have a known concentration of the acid or a base. And so for example here, I have this acid of unknown concentration, and here I have a base of a known concentration. So I know what the concentration is. I know the molarity of this base. I want to find the molarity of my acid. To do this, you have to have some kind of a compound added to it, and this compound is known as an indicator. It changes colors depending upon the pH of the solution. So if it's an acid or a base, it changes colors. And so if you have something that's acidic, it's colorless. Like this example here, we have, if it's acidic, it's colorless, but then it gets this deep purple color. And this, for this indicator, there are various indicators that change various colors. But this one's phenolphthalein, so it changes this deep purple color in a basic solution. And so if you have your acid, you add some indicator to it. As you titrate, you add this known concentration of base. And so as long as that solution is still acidic, it stays colorless. But right there, when they react together perfectly, it changes colors. Now if you go too far past it, you end up with that deep purple color. So that's what's shown here, is that this one is too colored. So you went way past your neutralization endpoint. And so here, this first one's a good endpoint where you just get that faint color. You know, you're right there at the endpoint. And when you do this, when you drop your base in there, as soon as it drops in there, you'll see it. You'll see a color change. But then you swirl it around, the color will go away because the base will all be neutralized by the acid. And so you keep dropping until when you swirl it around, that color is maintained. You just want the faint color. You don't want it to go too far to where you get to add too much of your basic solution. So now we're going to look at the steps involved in solving your typical titration problem. So what you're going to do first is find your reacting moles of base. And so you know the concentration, then you know how much volume you need to reach that neutralization endpoint. So from that you can find your moles of base that was used. Then from your balanced equation, you go from moles of your base to moles of acid, and then you know how much volume you started with the acid. You now know the moles of acid, so molarity is molarity divided by liters of solution, or the number of moles divided by the liter of solution. So now you can find the molarity of your acid. So let's look at some different questions. This first one says, write a balanced equation for the neutralization of hydrochloric acid with barium hydroxide. So first you need to know what hydrochloric acid is. So hydrochloric acid, just HCl. Barium hydroxide, barium is group 2, so it forms 2+ ions. Hydroxide, just kind of some memorizing those polyatomic ions, it's OH minus. So I need 2 hydroxides to balance out the barium. So it'd be BaOH2. So HCl has BaOH2. Now here I'm going to do the double displacement like I did in the previous videos. So I take my positive my first, or my negative my second. That's where I get my water. So remember, your neutralization reaction, you get water plus a salt. So your salt will be Ba2+. Take the positive your second, or the negative the first. 2+ charge here, minus charge here. So I need 2 chlorides to balance out the barium. So BaCl2. That gives me 2 chlorines over there, so I need 2 chlorines here. Gives me 2 hydrogens, 2 hydrogens. Let's see. But here I actually have 4 hydrogens because I have 2 here and 2 here. So I need 4 hydrogens on this side. That gives me 4 hydrogens, 2 oxygens, 2 oxygens, barium. So now it's balanced. So here I'm given a 5 milliliter sample of sulfuric acid requires 40 milliliters of 2 molar sodium hydroxide for complete neutralization. I have to write the equation for neutralization, and I'm asked to find the molarity of your acid. So this is your typical titration problem. And so, as first, let's go ahead and write our equation for neutralization. So sulfuric acid, H2SO4. Plus sodium hydroxide. Okay, so if I look at my ions, so H2SO4 is H plus and SO4 2 minus. NaOH is Na plus. NOH minus. That'd be the ions formed from that. So I take the plus of the first, pair of the negative of the second. So HOH, so that's my water. Then my salt would be Na is a plus, SO4 is a 2 minus, so I need 2 NAs to balance out the 2 minus, so Na2SO4. To balance that, so Na2SO4, so I need 2 over here. So that gives me 2 sodiums on both sides. So now that gives me 4 hydrogens total though. So I need 4 hydrogens on this side. Now that gives me 6 oxygens total. Now I have 6 oxygens total. And everything is balanced. So there's my balanced equation. Now I'm asked to find the molarity of the acid. So I'm given the volume of the acid. I need to find the moles of the acid so I can find the molarity of the acid. So how I do that is I'm going to start with, well, I'm given the volume and the concentration of it. Because I'm given volume and concentration, I can find moles. So 40 milliliters of sodium hydroxide. So I'm going to convert that to liters so I can use the molarity as a conversion factor. Remember, that's moles per liter. So 40 milliliters, 0.04 liters. And 2 moles per liter sodium hydroxide. So moles would be on top, so liters can cancel. So that's how I find the number of moles of sodium hydroxide I have. So I have this 5 milliliters of sulfuric acid in my flask, and I'm dropping 2 molar solution into it, and it takes 40 milliliters to where I just get that faint pink color. So I know it's completely neutralized at that point. So now I know the number of moles, so that was the first step, find reacting number of moles. Now find the moles of acid, so I'm going to use my balanced equation. 2 moles of base react with 1 mole of your acid. So now I've got my number of moles of my acid. So 2 divided by 2 is 1, so 0.04 moles of sulfuric acid. So now I know the number of moles. I'm given the number of liters in the problem. It's moles per liter, so I need to convert this to liters. So 0.005. So 8. So I get an 8 molar solution. So I'm given that the molarity of that acid is 8 molar. So 8 molar H2SO4. And again, a warning here that if you try to use the dilution equation to solve for this one, the MCBC equals MdVd, you will get the wrong answer because this one is not a one-to-one reaction. So that's your typical titration problem that you'll be asked to solve. Here's another one that involves similar concepts, so this is more of a stoichiometrical calculation though. So this is your typical titration problem though. So it says, what volume of 0.1 molar sodium hydroxide is needed to completely neutralize 5 milliliters of 0.2 molar phosphoric acid? Let's go ahead and look at that one. So first thing I need is balanced equation. So reacting my acid with my base. So if I look at my ions that are formed when dissolved, I compare my positive to my first, negative to my second, so HOH, so that's where I get my water. And positive to my second, negative to my first, 3 minus 1 plus, so I need 3 of these to balance that out, so Na3PO4. Now I need to balance that, so 3 sodiums are on the right side, so I need 3 sodiums over here. That gives me, if I look at hydrogens, 3 plus 3, 6, so I need 6 over here. That give me 7 oxygens on both sides, 1 phosphorus, so it's balanced. So what is the volume of 0.1 molar sodium hydroxide needed to completely neutralize 5 milliliters of 0.2 molar phosphoric acid? So this is kind of a reverse titration problem where I haven't did the titration yet, but I'm going to see how much it'd probably take if I did do this titration. And so where I'm going to start is where I have the volume and the concentration. So I have the volume and the concentration of my phosphoric acid. So that's where I'm going to start. So take this volume, so 5 milliliters is 0.005 liters. If you can just divide by 1,000. You don't want to skip that step. And 0.2 molar. So I put moles on top so my liters will cancel out. Now I go to my balanced equation because I'm going from one thing I have H3PO4, moles H3PO4. I want to know about sodium hydroxide, so I need to go from one compound to another compound. So I'm using my balanced equation. So I want to go from H3PO4 to NaOH. So I'm going to go 1 mole of phosphoric acid requires 3 moles of sodium hydroxide. Moles of H3O4, moles of phosphoric acid on top. So cancel, and 3 moles of sodium hydroxide on top. So moles of phosphoric acid on the bottom, so cancel, 3 moles of sodium hydroxide on top. So now that gives me the moles of sodium hydroxide. It says what volume of this solution do I need? So now I'm going to use this molarity as a conversion factor. I have moles of sodium hydroxide. So molarity is moles per liter. So if I have moles on top here, I need moles on bottom here. So 0.1 moles of NaOH per liter. Okay, so now that moles of sodium hydroxide cancel out, and I'll be left with the volume of that sodium hydroxide solution that I need. 0.05 times 0.2 times 3 divided by 30.03. So it looks like I need 3 significant figures in that answer. I only have one shown there, but I'm given this in milliliters, so I'm going to go ahead and give my answer in milliliters as well. So I'm going to multiply that by 1,000. So I get 30.0 milliliters. I'm showing 3 significant figures there. So that is it for titrations. If you have any questions on that, you can email me. I'll be checking my email some while I'm gone. And I'll see you when I get back. Bye.